Hello friends, I am Aryan Guru working as Assistant Professor in Sherrod Institute of Technology, College of Engineering. In this lecture we are going to see the contouring applications. In the previous lecture we have seen what do you mean by contour, what are the different terms used in the contouring, maybe contour interval and the horizontal equivalent. Then the methods of contouring, maybe direct method, indirect method. Then today we are going to see what are the uses or what are the probable application of contouring in civil engineering. Before going to the application of contouring, first of all we will see method of contouring again. So there are two methods we have learned, that is direct and indirect method. In the direct method there are two cases, and depending upon the area. If the area is long and cannot be controlled from a single station, then this method is adopted. In this method, the various points on any contour are located on the ground by taking labels. Then these points are marked by pegs. After this, the points are plotted on the map to any suitable scale by plane table. This method is very slow and tedious, but it gives accurate contour lines. Then we will see the procedure. Suppose a contour map is to be prepared for an oblong area. A temporary benchmark is set up near the site by taking fly level reading from permanent benchmark. The level is then set up at suitable position L from where maximum area can be covered. Then the plane table is set up at suitable station P from where the above area can be plotted. Then a backside reading is taken on the temporary benchmark. Suppose the RL of temporary benchmark is 249.5 meter and that the BS reading is 2.250 meter. Then the RL of height of instrument is 251.750. If a contour of 250 meter is required, the staff reading should be 1.75 meter. If a contour of 249 meter is required, the staff reading should be 2.75 meter, and so on. So this is to be calculated by taking the difference between the desired contour to be plotted and the RL of height of instrument. Then the staffman hold the staff at different points of area by moving up and down or left and right until the staff reading is exactly 1.750. Then the points are marked by pegs. Suppose these points are A, B, C, D. Then a suitable point P is selected on the sheet to represent the station P. Then with the LED touching P, rays are drawn to A, B, C and D. The distances PA, PB, PC, PD are measured and plotted to a suitable scale. In this manner, the points small a, small b, small c and D of contour line of RL to 50 meter are obtained. These points are joined to obtain the contour of 250 meter as shown in the figure. So in this slide we are going to see the sketch of direct method of contouring, in which the benchmark and TBM is shown, and in between benchmark and TBM fly leveling is to be carried out, and after that the instrument station, that is level, is to be set up at point L, and from point L the first reading on the benchmark is taken, which is going to give us the height of instrument. And once the height of instrument is determined, then the staffman is going to move along a boundary, and wherever the desired staff reading is obtained, then he is going to drive a peg at a point, say for A, similarly for B, similarly for C, similarly for D, for a particular contour. And then the plane table is set up at P, and the distances PA, PB, PC and PD are marked on the paper, and the points A, B, C, D are located, which is going to indicate the contour of a particular RL. Then we will consider the case number 2, when the area is small and can be controlled from a single station. In this case, the method of radial lines is adopted to obtain contour map. This is very slow and tedious, but gives the accurate contour lines. So in this method, the plane table is set up at a suitable station P from where the whole area can be commanded. A point P is suitably selected on the sheet to represent the station P. Radial lines are then drawn in different directions. A temporary benchmark is established near the site. The level is set up at a suitable position L and a BS reading is taken on the TBM. Let the height of instrument in the setting be 153.250. So to find the contour of RL 152 meter, a staff reading of difference between 153.25 and 152, that is 1.25, is required at a particular point, so that the RL of contour of that point comes to be 152 meter. Then RL of a point is equal to height of instrument minus staff reading, that is 152 meter. Then the staffman holds the staff along the rays drawn from the plane table station in such a way that staff reading on that point is exactly 1.250. In this manner, the points A, B, C, D and E are located where the staff readings are exactly 1.25. The distances PA, PB, PC, PD, PE are measured and plotted to any suitable scale. Thus the points small a, b, c, d and e are obtained, which are joined in order to obtain a contour of 152 meter, which is shown in this particular diagram. The other contours may be located in similar fashion. Then in this slide we are going to see what are the possible application of contouring. First is capacity contouring, second is drawing the section, third is earthwork calculation, fourth is intervisibility between two stations, fifth is measurement of drainage area, sixth is selection of route, and seventh is for strategic point. We can make use of contour map. Here, whenever we are choosing the dam site, we are supposed to study the location of a dam and the contour map of a adjoining area, and depending upon the direction of flow of that particular water at that particular place, we are going to select the possible location of a dam where the dam length is minimum and it is possible to store the maximum water within that particular catchment area in the upstream of dam. So naturally the area may be of cup shaped, obviously, which is going to retain the water at that particular location, and depending upon that particular capacity, the dam can store the water without any problem, and the water can be taken from the dam location as and when required for irrigation purpose. Then the capacity contouring. So in the given figure, the area enclosed is in between 100, 90, 80 may be measured by a planimeter. The volume of water enclosed between 100 meter and 90 meter will then be equal to the average of two contours multiplied by the contour interval. Similarly, the volume between other two successive contours can be calculated. The contour volume will then be equal to sum of volume between the successive contours. If A1, A2, A3 ... An are the areas enclosed by various contours and H is the contour interval, then the reservoir capacity will be given by V equal to H multiplied by A1 plus An divided by 2 plus A3 plus A4 ... So this is the trapezoidal formula. Another formula, that is prismoidal formula, is given by V equal to H by 3 in bracket A1 plus 4A2 plus 2A3 plus ... plus An. This is the prismoidal formula. So by making use of one of these formulas, it is possible to calculate how much water we can retain within a catchment area of a dam. Then we will consider the case number 2, when the area is small and can be controlled from a single station. In this case, the method of radial lines is adopted to obtain contour map. This is very slow and tedious but gives the accurate contour lines. So in this method, the plane table is set up at a suitable station P, from where the whole area can be commanded. A point P is suitably selected on the sheet to represent the station P. Radial lines are then drawn in different directions. A temporary benchmark is established near the site. The level is set up at a suitable position L and a BS reading is taken on the TBM. Let the height of instrument in the setting be 153.250. So to find the contour of RL 152 meter, a staff reading of difference between 153.25 and 152, that is 1.25, is required at a particular point, so that the RL of contour of that point comes to be 152 meter. Similarly, by knowing the contour map and by knowing the values on the contour, it is possible to trace the grade contour and selection of route. So whenever we are having, or whenever we are trying to set the alignment, then initial point, let us say the capital A, is considered on the contour line of 99 meter, and then we are going to choose what is the contour gradient which is required at that particular location, and by considering the contour interval of that particular map, we are going to consider the mark the point in this manner. First of all, we are going to see what is contour gradient 1 in 20. So it is going to indicate that 1 meter, when you go up by 1 meter, you are going horizontally by 20 meter. So the distance between capital A and small a should be 20 meter, and vertical distance between capital A and small a is 1 meter. In this fashion, after marking the small a on 100 meter contour, then again by taking some suitable scale as that of contour map, by considering the point small a, we can draw an arc having a length equivalent to 20 meter, and the B point is marked. In the similar way, the point C is marked by making use of B. Similarly, D point is marked by making use of C. In this fashion, we can mark the points on the contours so that we can reach from point A to point B, and it is going to indicate and when the points A and B are joined, they are going to indicate the contour gradient of 1 in 20. Also, use of contour map is for drawing cross sections. For example, there are two figures in this particular slide. One is plan and another is section. If you try to refer the plan, the cross section is shown, that is AB, which is going to pass through 101 to 98 contours. Whatever the lines which are shown, they are called as contour lines. And this is a plan, and at the top there is a cross section. So whenever it is required to draw the cross section, then you are supposed to consider the x-axis and y-axis, and by knowing the horizontal equivalent along that particular cross section, it is possible to plot the points, or you can extend the point of intersection in a vertical plane, so that it is possible to allocate the position of that particular point as a ground profile. So here, for example, in order to locate the position of A in the cross section, since the RL of point A is 101 meter and we have considered the datum of 90 meter, so by taking the difference between 101 and 90, that is 11 centimeter, we have to go up so that the point A is marked on the cross section. Similarly, in all the intermediate points are to be marked by taking the difference between the value of contour minus datum, and accordingly the ordinates are taken and the points are marked. Also at the end, the point B is also marked having a contour of 98 meter. So in order to locate the position B on the cross section, then 98 minus 90, that is 8 centimeter above X has to be marked, and when we are going to join all the points, then while doing this, we have to draw a line between the 2 points bounding the desired profile area, place a folded sheet of paper along the line, mark each contour line intersecting the paper. From each mark, indicate the vertical height with a dot on a scale, connect the height dots with a smooth line. Also, the use of contour map is used for calculating the earthwork volume calculation, many of times when we come across the road construction or proposed road construction or railway construction, then it is possible or it is required to calculate what is the quantity of cutting and what is the quantity of filling, and that is possible by considering the formation level and the ground level at that particular location. Similarly, by knowing the contour map, it is possible that we can ascertain whether the points A and B, they are intervisible from each other or not. So for that we require the contour map, which is shown in the slide below. For example, so for that we are supposed to draw the cross section as explained earlier, considering the horizontal equivalent and the value of contour interval. So value of contour intervals are plotted on y-axis, whereas value of horizontal equivalent is plotted on x-axis, and accordingly depending upon the values of contours we can find the position of line, and then the points A and B are joined by a straight line, and if the ground is not going to cut in between A and B, then we can say that the point A and B are intervisible from each other. If there is any obstruction, then it is possible that the 2 points may not be intervisible from each other. So here, in a similar way, intervisibility of points is obtained. So here the contour map is given, wherein we come across the contours having RL 645, 640, 620, 600, 580, 560, 540, 520. Means in this particular contour map, the contour interval of 20 meter is there. That is difference between 580 minus 560, that is 20 meter. And by taking a scale of that particular contour map, it is possible to calculate what is the horizontal equivalent. So horizontal equivalent is plotted on x-axis and contour interval is plotted on y-axis, and depending upon the location where the contour is going to cut at a particular cross section, you can calculate the horizontal equivalent, and corresponding to that, when the points A and B are plotted by drawing the profile, and when the points A and B are joined, then it is possible that we can ascertain whether the 2 points A and B, they are intervisible or not. This slide refers to the closed contour having RL 96, 97, 98, 99, 100 and 101. It is going to indicate that the ground feature is pond, and when we are interested to calculate how much water we can store, so it is made possible by finding the area which is lying below lying in 96. Similarly, we can find out what is the area covered by 97, 98, 99, 100 and 101. And when the areas are calculated, just like A1, A2, A3, A4, and by making use of trapezoidal formula or Pismodel formula, it is possible to calculate the volume, how much volume you can store. That is called capacity computing. This slide represents the field data of indirect contouring, wherein the given area is divided into rectangles and RLs of corner points are calculated and which are written at corner points, and then by considering the values which are plotted just like 608.3 and 617.3, means if we consider the contour interval say 2 meter, then it is possible that we can plot the contour of 610, 612, 14, 16 likewise, and so that, and by eye judgment or by making use of arithmetic method, we can locate the exact position of a particular contour in between the two plotted RLs. Here in this particular slide we are going to see the contours, and we are interested to calculate the drainage area, and for finding the area we are supposed to make use of the instrument, namely the planimeter. So planimeter is one of the instruments by which we can calculate any irregular area. This is the typical contour map wherein the green color indicates the water storage. So by finding the area lying within that particular contours, it is possible that we can calculate the volume of water to be stored by multiplying the height by making use of S model as well as trapezoidal formula. Another use of contour map is to highlight to have the strategic planning, and for that we need to prepare the contour maps. So this is the typical location showing the boundaries between China, India, Tibet and Bhutan and Myanmar and Pakistan. So in viewpoint of disputed areas, the strategic points are to be decided, and which is going to highlight what is the highest elevation of that particular point, and from that we can see the area which is covered by the country like China, Tibet and other countries, so that we can decide the strategy how to defend the attack by the enemy. This is a slide which is going to represent or going to show the last Indian village in the border road organization. You will observe that you will find the large difference between the road level in the village, at the same time what is the height of that particular mountain. So considering such type of aspect, we can decide the strategic points where they should be located and how the attack can be done during the war position. Here in this particular slide we are going to see the contours, and we are interested to calculate the drainage area, and for finding the area we are supposed to make use of the instrument, namely the planimeter. So planimeter is one of the instruments by which we can calculate any irregular area. Thank you friends. In this lecture we have seen the contouring application and how to proceed for direct method of contouring depending upon the area.